Good afternoon, class. Today we're going to continue our discussion on computing for the returns, simple returns, and log returns of assets. So let's just have a quick review of what we have discussed so far. We said that the quant mode package, which I already loaded here, so let me check. Quant mode, if you can see here, quant mode is already checked. So make sure that you have loaded the quant mode package via the library or require function. We can use the get symbols function from the quant mode, which allows us to download stock prices or whatever assets from different sources. The and the default being, let me just write here, source is equal to Yahoo, which is the default. Okay, so what we did last time was to create an object, a vector of characters containing the ticker symbols of our stocks: Apple, Google, Microsoft, Intel, Amazon, Netflix, Meta, which is Facebook, Tesla, and GSPC. We're going to download the stock prices for these assets. Now we're going to make use of the lapply, which is list apply. Okay, so list apply uh, to the tickers this following function. The function is get symbols. Okay, so we're going to apply it to x, x being the function which is lapply to tickers. Medyo ganun yung concept, no? And then from 2016-11, we won't have problems with Tesla because at that time Tesla was already listed. From 2/23, 12/31, daily periodicity, source is equal to Yahoo, and auto.assign is equal to false. So if you run this, okay, which we did last time, so this is just a quick review of what we did last time. It will generate first the tickers object, which will which will fall under the values because this is just a vector. And then under data, you'll have the list. Okay, it's still running. Let's give it a few more seconds. Okay. Oops. Okay, I was encountering this same problem a while ago. So let me just pause the recording and then, okay, finally it ran. So I was able to uh, create an object called my stocks, and it's a list. So remember last time we looked at this, and this is a list. As you know, a list is a data type of data structure which can contain other types of data structure. So it can contain mixtures of vectors, data frames, arrays, matrices, XTS object, other lists. So in that regard, a list is really very flexible. Okay, so going back to our code, what we did last time was, okay, I will need to delete this. Okay, so my stocks, see this is our list of 9 objects. It's an XTS object containing 2012 observations by six columns, because we know that an XTS object contains the OHLC, volume adjusted, open, high, low, close, volume, and then the adjusted. Okay, so we can replace the names here. We use the column names. Okay, sorry, no, not the column names, because column names is used for data frame. So we identified the names of my stocks to be this. Okay, we replace it with, we're going to replace it with this one. So if I run this, then check my stocks. So is it finished? Okay, I think it is. Okay, so it now replaced the name, which is a better way to represent your list. Okay. So let's dispense with this. Now what we need is we want to create an XTS object or consisting of the adjusted prices. Okay, you can make use of the closing prices or adjusted prices. Usually in finance, we either use adjusted prices or closing prices. We're going to make use of the L apply again. Okay, so what we did last time was we created this object adjusted prices and then use L apply again to create another list coming from my stocks, and then we just use the adjusted prices. Okay, so if I run this, I will now generate adjusted prices here. Okay, it's also part of data. A list is usually part of the data section, unlike the vector, which is part of the value section. And if we check what's inside the adjusted prices, it's the same as your my stocks, but this time it's now 2012 by 1. Okay, it's an XS or zoo object. So you can now see the values for Apple. These are now the adjusted prices of Apple. So let's create in an XS object out of this list. We cannot work on a list. We have to generate an XS object for us to compute to do some manipulation on our data. So we're going to do that. Use the do that call. Okay, we use the do that call, and then in particular, what will be called? What will be called is the function merge. So what are we merging? The object adjusted prices. So take note, the object adjusted prices is a list consisting of 2012 observations by one column. What will happen here is that it will merge all of this and create one object out of that. The object is called prices. If I run this, and since the adjusted prices consist of XTS object, what will be generated will be an XTS object itself. So prices. So now we have an XTS object. I open this. All right. So we have Apple that adjusted. It defaulted to this to the names of the ones in the list itself. Okay, and I want to change that. What we did last time was to change the variable name, column names into the small letters. Okay, so column names of the prices is this one. Okay, so let me run that. Easier to understand our data. So prices have been overwritten, and now our column names are just the small letters. Okay, so that's just a review class. May I pause for a while and ask you, class, if you're able to, if you have this already, this object, if you have these objects already, then I hope you understood the process. Are we clear so far? Whether you have questions or not, please feel free to chat in the chat box. Okay, so majority, right? Patrice, were you able to address the error? Did you just rerun?
Yes, sir. I just had to rerun it.
Okay, thank you. So sometimes it's caused by the uh, internet. Okay. All right. So let's continue, class. We started last time discussing discrete returns. Generally, there are two types of returns. You have your discrete or simple returns, or others call it the standard returns, and the log returns. So what's the formula for discrete returns? We discussed this. It's just the ratio of your current price divided by the previous price and then minus 1. We said that this price is easier to manipulate, easier to use compared to this one, because you will have to put parentheses here, okay, because of the PEMDAS rule. So I normally suggest that we use this formula. So how do we use that class? For example, if I go to prices, and if we're going to get the returns of Apple, let's just annotate this. Okay. So let's just let me just uh, consider a small subset. If our data set is only up to here, and we'd like to create a an object containing the simple returns of this data, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 observations. So from here to here, 12 observations, 12 prices. Then if you compute for the returns, you will only have 11 returns. Okay, so it's always -1 the number of dates. Because when you compute for the returns, it will always involve a period, P sub t over P sub t minus 1. Okay, then here is your -1. So it will involve a period. So how many periods are there here? If you count the number of periods, this is one period, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there will be 11 periods. So when you compute for the returns, it will always involve a period. And the period involves 2 dates. Okay? So that's why if you have, as I said, if you have 12 observations, you'll have 11 returns. Okay, so the formula calls for P sub t. Okay, technically our P sub t only ranges from, let me use a different ink. Our P sub t, okay, are those values that will have their previews, no? Okay, this one can be considered a P sub t because it has a P sub t minus 1, a previous one. This one class cannot be considered a P sub t because it has no prior value. So technically our P sub t's are only up to this one. Those are our P sub t's. And our P sub t's minus 1 will of course be from here up to the last one here. Okay? So P sub t, what's this? The first circle here, let me just call it a circle. And this P sub t minus 1 will be your second circle. Now, my question is, why cannot this be this first value here? Why can't it be considered a P sub t minus 1? Okay? It cannot be considered a P sub t minus 1 because based on our subset, it does not have a P sub t. Okay? There's no value succeeding it. So wala siyang succeeding value. So it cannot be a P sub t minus 1. Okay, this value. All right, so you have the vector or the array of P sub t's divided by P sub t minus 1, and then subtract 1 to 8. That will give us our returns, simple returns. So the first one class will not have any returns because, as I said, you don't have any prior value to that. And the formula can easily be applied in R. So what's the formula for that in R? Going back here. So we did this last time. It will simply be class the prices of your Apple. Okay, so we're just using the Apple. We're just computing for the returns of Apple. So prices $Apple contains everything here. Okay, from the beginning, this is the beginning up to the end. The end is the latest value. Okay, this is the end value. Okay, so your prices Apple contains 2012 observation. And then when you divide it by the log, so what's log 1 class? Log 1 will only include the day before the last value. Okay, so it will only include this one up to the end. Okay, so you have here, you have here, for the prices, there will be 2012 observations. For the log one, there will only be 2011 observations. Okay, so when you divide P sub t over P sub t minus 1, this will have the value, okay? This will have the value. This will have the return. The pairs will have the returns. But when we reach the last one, okay, the prices will still include this one, the last value here, but you cannot divide anything out of it because it doesn't have the P sub t minus 1. So that's why you're having the NA, okay? You're having the NA value because R is not able to see any value before that first value. So this is the formula class. So let's run this. This is already discussed last time, so I'll just be going through this very quickly, just by way of review. All right. So as I said, there will be an NA here, and normally, class, what we do is we remove the NA because this will generate some problems when we do functions later on. Okay, so it's the easiest way to remove it is just create another R. Okay, if you want to name it, if you want to overwrite the R with the NA, you can just remove the first element there, -1. Okay, or if you want a function to do it, you can use the NA dot omit. Okay, so NA dot omit. Okay, which is, so you put you put NA dot omit here. Okay. Let me see, class. Did I put? Sorry. So if this is our original function, Control C, Control V here. Okay. I'm going to put NA dot omit here. NA dot omit. Okay. Open parenthesis and then close this. So that means one parenthesis will do. Okay, because that's just what we, let me check. Am I right? I'm checking because why did I put here -1? So -1 prices. Okay. All right. So I was thinking, class, why did I put two parentheses here? Okay, so this should work, class. I'm sorry about that. Last meeting, we used two parentheses when in fact, I think we can use just one. So let's check, class. So this should run. Okay, it ran, class. So apologies for that last one. There was an extra parenthesis here, which still is correct, but why should you put extra open and close parentheses? Okay, so let's check the value of our R. The NA should have been removed there. Okay, the returns is -2.5059. Let's see. Let's check. The first four returns are negative. Let's just validate that. Did the price drop from January 4 to January 5? It dropped. So that's a negative. January 5 to January 6, it dropped again. So that's a negative. January 6 up to January 7, it dropped again. Okay, so that's a negative. So for the first three periods, there was a drop in prices, so you have a negative. And on the fourth period, 21.95, 22.06, it's an increase, so that should be a plus. Just validating our values here, negative, 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 and then positive. So we're okay. All right, then you can see here, class, that the values here has negative 0.2. What does this mean? What does this mean, class? So you know, class, just to be sure that you, uh, because sometimes students make a mistake saying that the return is negative 2.5. It's not negative 2.5. It's a scientific notation. You have an E here. So it's a negative 2.5, okay? And then E to the minus 0.2. That means you move negative here, move 2 places to the left. There, 1, 2. Point here. So it's actually negative 0.25, 259, etc. If it's a negative 2 class, so you remove, you move to the left 2 decimal places. But yeah, so that's, we can say here that this is 2.5%. Okay, because this is actually 0.025. Okay, so then let me close this. Go back here. All right. Okay, then a simpler way actually to do it instead of this quite long formula is just to use the delt function. The delt function is just the same as this. This is the delt function because you're getting the delta or the change between price at time t over price at time t minus 1 minus 1. That's your delta. Okay, so here, let's create another object. Let's call this, maybe, am I using AppleRet? Let's just use AppleRet so that we can compare AppleRet with R. Okay, so let's do this, AppleRet. And then if you view AppleRet, you can see that there's also an NA. Okay, there will be an NA and the values are the same. Okay, of course, if you ask me which is easier, then delt will be easier. Okay, but why did we study this? Because we wanted to know a way to compute for the returns using the lag. The lag is very important because we're going to use that. Delt. Okay, so Patrice, can you share your question? Everyone, please. And then I'll ask the class how to answer this question. Okay, questions are very important to us because these are learning opportunities for us. Okay, Patrice, kindly share your answer. Share your question. I mean, okay, class, this is the question of Patrice. I got an error for the code, error in delt, could not find function delt. So how do you address that, class? How do you address that question? Could not find function delt. What's one way to address that? What should you do first? What should we do first? Any suggestion? Any suggestion from the class? Kasi could not find function delt. What does that mean, class? Okay. Kulang na package, okay? Anong package yun? How do we know from which package is delt coming from? Diba yun, diba? Kasi could not find the function delt. That means that there's a missing package here. Okay, so where is it coming? Where is it coming from? That function delt. What do we do with it, class? So is quant mode, okay. Ang question is delt coming from quant mode. So we can check, class. Delt, this is a package. So I saw it already. Delt. Question mark delt. Okay, let's see. Okay, so delt, this is delt. So this is coming from here. Yeah, this is coming from quant mode. So which means, Patrice, that uh, you have maybe you have already here the R, the Apple, the objects, and you did not load quant mode. Okay? Yes, exactly. So that's what I said a while ago. But thank you for that question, class, because this allows us to learn. Okay. For example, we learned that delt comes from the package quant mode, and definitely you'll not be able to run delt without having to load quant mode. Okay. So thank you so much for that question. Okay, so let's prices and object. Okay. What's the answer here, class? Question ni Adam. Prices and object part of a separate package. Anyone, class? What's the answer there? Yung prices ba, class? Is that part of a package? What's the answer, class? So let me ask you. Russell, what's the answer to the question of Adam? Cabrera, Mr. Cabrera, Russell, what do you think is the answer to that question?
Hi, sir. I'm not really sure because I'm still trying to figure it out.
Okay, sige. Who no? Sige, thank you, Jenica. Paki-share yung answer mo to everyone. Why no? Okay. Christian, thank you. Again, class, please share your answer to the class. That don't just answer directly to me. Please share your answer. All right. So si Jen, sabi niya no. Si Christian, prices is an XTS object. Okay, how do we determine that, class? Is there a function? Is there a function called prices? Let's see. Let me uh, let me ask the help function. Prices meron ba? Okay, if you take a look at this class, mayroong price bands. Okay, so doesn't seem to be a prices function here. Okay, but assuming there was, class, kasi pwede yun eh. Assuming there was, class. So that was a very valid question. Is it part of a package? Okay, in our case, it was not. Kasi how was price or prices used in our case? Okay, remember, we created this object. Okay, prices to class object to kasi after that is is our assignment operator. It will only become a function class if we have here price, okay, and then all right, and then we use it as a function, but we're not using it. We're not using it as a function. Here we created the object, so it's a created object. In fact, it's here, class. It's here, the prices. So data siya. So it's an XTS object. Okay. I'm not saying that there is no function called price. There could be, no, in other packages, but in our context, it's not coming from a package. Rather, it's an object that we generated. Okay. Did that answer your question? Who was that one? Who was the one who asked? Adam, did that answer your question? Okay, thank you. And thank you again for those questions, class. And thank you for those who are participating in giving answers. That's very good. Plus, we learned from this experience. Okay, so going here, class, we have used the delt, and then have we printed that? Yes, we have printed it. And then we can also just delete there's an NA here, so we can rename the delt that one. It's a very an ugly way to name your column. So here we can just rename the column, call names of Apple red. So if you want to do that, for example, okay, so if Apple can remove the first, let's just use the Apple underscore red, -1, okay? So that will remove the NA. And then also call names AAPL, AAPL red, and then assign it alt minus, assign the name, can I just use Apple, okay? AAPL. All right, so if I run this, oops, careful. If I double run this class, if I run this and run this again, it will remove 2 times. So let me check. Okay, I haven't run it. Run this once. Okay, so that will remove the NA value there. Okay. Apple red. So let me click this. Yeah, okay, it just registered a bit delayed. My internet is not that good now. Okay, and then going back here, again, the name is not good. Okay, so let me just replace this to column names. Okay, we now have the column name. Okay, so these are small things, but they come in helpful, and you should know, class, how to do them. All right, let's go to log returns. And we said last time that log returns is defined by the log of the current value minus the log of the previous value. Okay, and it can be written by the principle of logs, class. The log of a value minus the log of another value is the same as the log of the value divided by the other value. Okay, so by the way, class, in R we use the term log. I think we should have used here log. Okay, if I replace that by log, okay, in R the when you use log, the default is it's using base E. Okay, I have explained that to you before. Okay, so when we simplify this, let me annotate this. So this one is just the same as the singular quotient of P sub t over P sub t minus 1 and then log. Okay, notice its difference with R sub t. Okay, should have used log returns here. Log returns. The difference between the simple returns is that simple returns is P sub t over P sub t minus 1 and then minus 1. Okay, then if I add this one minus P sub t minus 1 and then plus P sub t minus 1, they will not affect actually the value of the numerator because this is just 0. So we're just adding negative and positive P sub t minus 1. And then if we simplify this, we distribute the denominator, this becomes P sub t minus 1 over P sub t minus 1, that's your 1. And then P sub t minus 1 divided into P sub t over P sub t minus 1 divided by P sub t minus 1. That's your R sub t, right? That's your returns. That's your simple returns. So you'll have now ln of 1 plus your simple returns. Now, applying mathematics, it can be shown that ln of 1 plus R sub t is approximately equal to your R sub t. So what does this tell us? Your log returns is approximately equal to your returns in cases where your returns are very small. So for small returns, the log returns class is approximately equal to your log returns. All right, so let's try to do that. Okay, clear all the logins, and then let's go here. Okay, by the way, are there any questions here? Did I share this LaTeX with you as before? I did, right? Class, did I? Can you chat, please? Have I shared this LaTeX with you? Okay, yes. Okay. All right, so let's compute it, class. Okay, I should have let you do this on your own. Okay, so how do we get, let's create this object. This one, did I share it already? No, I don't want to share it. This one, so compute for the log returns of Apple. Let's call it r.log. So you get here, it's simply the log of, this is your p sub t, this is your p sub t minus 1. There. Okay, and then just put it in parentheses. So this is now your log returns. Okay, kindly run this and tell me what happened. What are you getting? What are we getting, class? Can you chat, please, the first value in the log returns, aside from the fact that it will be NA. NA siya kasi ganito din, may lag tayo. No? The first value will not have any lag. Can you please chat the first value of your log returns? Everyone, please. Don't, not the NA. Okay, waiting for the others to chat their answer, class. Waiting for the others. 0.99. Okay, may kulang dyan, Migs, no? Christian, mali din, ah. Okay, it should be, class. How about the others? Waiting for the others to show their answer, class, sa chat box. Dalawa pa lang. Error si Patrice, si Justin, 2.5378, si Jaron. Okay, so you have different answers, class, no? Okay, bakit kaya iba? Okay, if I run this, kasi class, ano ba yung formal ng log returns? It's just the log of your p sub t over p sub t minus 1, diba? Eh, ang p sub t natin, ito, this is our p sub t. The prices, $Apple. So this is that vector of prices. And then, yung p sub t minus 1 natin is this one. Lag of prices, Apple. Then we have to define k is equal to 1, no? Kasi lag 1 yan, eh. Okay? So this is your p sub t minus 1. Your numerator is p sub t. So, and then, we put the log here, and then open and close parentheses. Okay, I'll give the others another chance to retype their answer, and let's see what happens. Okay, so yung iba, okay, so most of you are getting the answer negative 2.53, okay? So let me put here head. Okay, never mind, not the head. Okay, so let me run this, and if I print here the r.log, I'm getting an NA here, and the first value is negative 2.53787. Again, it's negative 0.2. Your R and your R log should have at least the same negative signs, and they should be quite close. Okay, so our simple returns is negative 2.5059. Our log returns is negative 2.5378. Okay, I mean 0.0253 because this is a negative. Okay, so if I put the NA dot omit here, okay, I'll just put NA dot omit and put parentheses here, and at the end, okay, run that, and now have an R log where the NA is missing. It takes some time. It takes, wala pa, nag-R log na ba ako dito? Yeah. Error na. Control enter. Ba't wala? Ano nangyari? Nag-NA dot ulit na ako. Sometimes it takes long. So, were you able to remove, ayan, tagal, oh. So again, it's because of the internet connection ko, no? Exactly. Okay, so far class, are we clear? Any questions? Okay, then as I said a while ago, class, log returns are approximately equal to standard returns. Approximate class, when they're very small. When the returns are small, then they will be approximately equal. Sorry. Sorry, not that class. Yun yung kanina. So let me copy this note here, Control C. Okay, you may put that note if you want. Okay. So this one I wanted to, I should have given this as an exercise, but in the interest of time. Okay, we're creating an object called X here. Let's compare the R and the R log class. Okay, so here, X, and then X, I'm creating an object called X, and then I'm putting it as a data frame, data.frame, and what are the columns R and R.log. Okay, so let's run this class and try to see class. Let's put here a, so it's if I run this, and then if I print it here, right? So you can see here, Apple and Apple.1. We don't want that. No, we're going to change this into R and R.log. But let's compare class. Let's compare this. Okay, let's print it here. Okay, so let's change the column name so that we can easily distinguish. So the first column should be rep. We use a column names. And then the second one should be log.rep. Okay, and then let's just print the first 10. I run this. Okay. So take a look at this class. Please chat first if you were able to get it. If you were able to generate the data frame. Consisting of return and log returns. Feedback, please. If you were able to generate this data frame, and I just use the head function to just print here the first 10 observations. Okay, good. Thank you. Thank you, Pinying. How about the others? Waiting for the feedback of others. Okay. Thank you. I hope everybody's able to follow along. Okay. All right. So my question is, for example, dun sa first period, yung January 4 to 5 or January 5, uh, which which returns is higher class? Which return is higher? Is it returns or log returns? Higher ba, Jenica, ang returns kaysa log returns? Why, Jenica? Returns. Okay, si Jenica lang sumagot. Why, Jenica? Why is returns higher than log?
Sir, if you look at the first uh the first column, the first row pala, sir. It's 0.0250, but it's negative, and then the log returns is negative 0.0253. So the returns is higher.
Okay, so take note, class, this is negative. No? So if we are lazy to just decide, let's just copy this, Control C, and then let's just ask R, Control V, is, okay, this one greater than that one. It's true, okay? So your returns is greater than your log returns. I just use that mathematical inequality to check if that's true. Okay, Jen is correct. So remember, class, pag negative, the higher the absolute value, the lower it is. So generally, class, you can see here, even in the positive returns, this one, 0.00528, this 527. Okay, so generally, returns are higher than log returns. Okay, 2187, 216. Okay, so I hope you got that. But in very, very small returns, they tend to be approximately equal. Okay? Any questions about that, class? Clear ba yun so far? Yung concept that returns, simple returns are higher than log returns. Kindly chat, please. Okay, good. All right. So far, what we have learned is to compute for simple returns and log returns using formulas. Whether we use the price divided by the lag, or we use the delt function, we can easily compute for the returns, whether it's, as I said, simple returns or log returns. All right. However, quant mode class has many functionalities. So it's really very easy to compute for returns, whether it's log or simple. So we can make use of, these are the functions. Some of them, you have period return, daily return, weekly return, quarterly return. So which means, class, that now this now will make things really very easy for us. Because suppose we have our data, the Apple data a while ago. What will happen if I ask you to compute for the weekly returns? What do you think will happen? Do you think it will be easy to do that if I ask you to compute for the weekly returns? A while ago, we just computed for the daily returns. That's very easy. Okay, so what do you think? Let me ask, see, easy, Ms. Bernales? Do you think it will be an easy task to compute for the weekly returns of our Apple stock?
Yes po sir, kasi may functions po yung quant
The
mode.
function without the function. Yung kanina naggagamit tayo ng formula natin. Actually, I should have asked you this question even before showing this. Nauna kasi yung pagsabi ko. No? I forgot to ask you that question. Okay? So just by using our, kasi tingnan nyo class yung, yung, kaya nawala na Apple object natin, asan na yung prices, no? This is our data. Okay, how do you compute for returns there? Paano? Weekly returns. How? Quarterly returns. You have to sift through this rows of data, right? To find, ano ba, Monday ba or Tuesday, every Tuesday ba or every Wednesday? Okay, so to compute for the maybe annual returns, that would be quite easy, no? Pero yung weekly returns, bi-weekly returns, monthly returns, that can be quite difficult if we're going to do that manually here. Daily returns, okay lang yung formula, no? Kasi we're including everything. But when we're now selecting from this data and choosing, for example, every Friday lang. So, paano mo hahanapin yung every Friday dito? Diba? Of course, you can make a function. Okay, you can do that. But that can be quite tedious. So, enter now special functions like the functions by quantmod. So, this is now where you can see the importance of packages class. Kasi, quantmod already gave us functionalities that we can use. Okay, so these are some of the functions, no? All return, yearly return, annual return, quarterly, monthly, weekly. So let's just explore. Okay, let me share this with you. Control C. Chat. Okay. All right. So let's try to see the syntax of period return. Let's study the syntax. Right? Control Enter. Or you can type it here in the console. Okay, take a look at this class. So period return class comes from the quantmod package. Okay, so it calculates periodic returns. Okay, given a set of prices, return periodic returns. So let's just, so ito sabi niya class, may daily, there is weekly, monthly, quarterly, annual, yearly, etc. And it explains here the arguments. Okay, so period return is the underlying function for wrappers, all return, etc. Okay, so may all returns pa, no? Okay. All right. So if you use period return, then you have to define ano ba yung period return natin, monthly ba yan or weekly. So you can, let's copy this, Control C. And lagay nyo lang dito class. That's what I did here. The syntax for period return is this one. I just copied it here for us to be guided. So you'll have here the data, your X, and is it weekly return? Is it monthly return? So you can use this class as a wrapper. So it means that you can use period return, whatever weekly, monthly, daily, you can use it here. And then you can identify the type, whether the type is arithmetic or let's look at this class. Type here, take a look at this type here. Okay, verse. Okay, hindi siya sinabi dito, no? Okay. Okay, so you should look at the PDF of the of quantmod itself, and some explanations here. Okay, so there are examples here. QQQ is a ETF din siya, no? Okay, but let's go here, class. So for example, let's get the discrete, the daily, discrete, and the log returns of Apple adjusted prices. We have the data for that already. So this will be the function for that. So you have to write it on your own class. AppleRet. So we have already AppleRet a while ago. So let's just use AppleRet one to distinguish from the AppleRet object that we have. My internet really is very slow. We have AppleRet already, so I'm going to use AppleRet one. So if I want to compare class, okay, we're going to use the here I use the daily return. I could have used the period return, but let's just use the daily return. So what's our X? Our X is prices Apple, and then the type is arithmetic. So that's simple class. Okay, the others we don't need if it's defaulted. Kasi dito daily returns, no? Here, daily return. This is our object. Subset is if we want only to subset a particular portion of your data set. So this can be very powerful. And then type, and then leading will explain in the next time. Okay, type arithmetic, that's what's important for us. All right, so could you kindly do that, class? Okay, so if I run this, so what did I use a while ago? 1, so this should be 1. This should be 1. Call names AppleRet1. And just give the first 6 observations. Yeah, that's a default already. 6. Okay, so let me run this first. Okay, so we now have AppleRet1. And if I print AppleRet1, okay, same thing, class. Take note, although it has a value here, okay, it has a value there. But be careful, class, because that 0.00 is not really the value. Okay, this is actually it zeroed out the NA, so we still have to remove this. Okay, I hope you understood what I said, class. We're not going to include this, although it appears as a number, because quant mode automatically converted that NA into a 0 value. And we don't want that because that's not necessarily 0. Okay, so I'm just removing the first one there. Okay, and then also replace the column name is not good. Also, it's daily.returns. Let's not give us the name of the asset itself. Okay, so let me run this. Ay, mali. Mali. Where am I? Okay. Ganda lang. Nagdamali ako dun. Okay, so I'm here. So I have I removed the, okay, I haven't removed the NA. So I'll remove it and then replace the name of the column and then print the first 6 observations. Control Enter, and here we go, class. Okay. So if you compare class, they're the same. Same as our arithmetic returns, which is your R 25059378 93. So this was rounded up 378 or 38. Okay, pause for a while. Are there any questions? Were you able to use daily returns, class? Kindly chat, please, if you were able to use daily returns. Okay, waiting for your feedback, class. Okay, I see only one response. Okay, thank you. Okay, so close this. Where did I run? Okay, if it's log class, if it's log, then instead of using type is equal to arithmetic, just use type is equal to log. Okay, so same thing, Apple. So here I'm using LRET, but it's quite confusing. So let me just, okay, anyway, those are just names. Apple underscore logret. So I'm using daily returns. Same thing. The only difference is that we're going to use the type is equal to log. And then again, remove the first column here and then change the name, because if I run this, the name, I now have here LRET, Apple LRET here. The name is also daily returns here, daily.returns. It defaulted to that name. So I'm changing the name. I'm removing also the NA and changing the name. So same thing, class, same thing. The only difference is that here I use the log return. And if I get the head of AAPL ret, AAPL underscore logret, just the first three, and then also semicolon, get the head of r.log. You see, let's see if they're the same. First three observations. Let's just compare. Okay. So class exactly the same. Okay. So we could have used the formula that price divided by lag, everything in log plus, or just use the function daily returns. Okay. Daily return, and then just identify the type, which is log. So we're getting exactly the same. Okay, pause again for a while, class. So clear? Are we clear so far? So you can see here the advantage of really making use of the functionalities of quant mode. This time, just the returns. Feedback, please, class, if you got what we're saying. Okay, good. Thank you. Thank you for the feedback. All right. So now let's see the all returns. Okay, take a look at this. So let's create this object, Apple ret all, so that we have the same name. And then the function is all returns. Okay, prices, Apple, and then type is equal to log. And then what do you get, class? Let's run this and see what happens, class. Roll enter. And then if I type Apple all ret, you can see now, okay, there, class. All right, you can see that here that you have daily, okay, you have weekly, you have monthly, quarterly, and yearly. Now notice that the others have NAs, many NAs. Why? Why, class? Because this is weekly only, for example. Okay, so the weekly, of course, will have less returns. Okay, less returns compared to the daily. Okay, how about monthly? Okay, you can now see here that, so weekly, ano kaya tong 1/8, no? And then 1/15. So it will be interesting to determine ano kaya yung dates na ginagamit niya. How about monthly? What do we notice about monthly? 129 class, no? 129, and then what's next? 229, okay? And then 3:31. So what do you notice, class? It's always at the last day, last trading day of the month. Okay? Ganon din si quarterly, class, no? Si quarterly naman, ang first niya will be March 31. So wala yung quarterly, walang previous 2 months, no? Every 3 months lang yan. Okay, so the rest will be NA. So that's what we get when we run all returns. It's a comparison of the returns on a daily basis, weekly basis, monthly basis, okay, quarterly, etc. All right. Questions, class? Are we clear with this so far? Let me just, if I run ahead here, medyo marami siya, no? First 6 observations, quarterly, yearly. Okay, were you able to get it, class? Paki-chat naman, please, if you were able to get the all returns. Okay. All right, may you please comment, class, which is easier, using the function date return or using the formula that we generated a while ago? Which do you think is a lot easier? Is it a lot easier to use the return functions of quant mode? Daily return, weekly return. Okay, kasi we said a while ago that if we're going to manually compute for the weekly return, that can be very, very difficult manually. Of course, you can create a function out of that. But we already have that function. It's already given to us by quant mode. Okay. Anyone who'd like to comment on that, please? From your assessment, which will be easier? Using the daily, the different period return of quant mode? Quick, class, quick, paki-chat yung comment nyo. We have a few more minutes. I'd like to at least makapagsimula tayo sa performance analytics. Alright, thank you, Christian. Pero paki-share yung answer sa lahat. Ha? How about the others, class? Isa lang ba may opinion about that? Isa lang may naramdaman dun sa ease of use ng any of the options? Ito yung sinasabi ko, class, na kung pwede, and ito na naman yung yung pahirapan na naman humingi sa inyo ng feedback. About the others, ano yung opinion nyo? Hello, class. Tagal naman ng comments. Simple lang, class, yung question ko. Is there anybody listening? Si Christian lang ba na sumagot? What's the take of the other class, of the classmates, the other students? Wala pa rin, walang sagot. Okay, nagcha-choppy ba ako? Sino? Okay, the others class, ako ba nagcha-choppy? Okay, anyway, so let's go here. We have a few more Okay, sige. All right, now take note, class, that the functions will only compute for a singular asset. So remember, class, ang ano natin, prices, di ba? Ito yung object natin. We have here several assets, 9 assets all in all. Now, will this automatically compute for the returns of all the 9 assets? No, it will not, class. It will not. So, for example, Control C. Okay, let me chat that with you. Okay, anyway. All right. So as I said here, if you have an object, let's say an XS or a data frame that has several assets, it will not compute all of the assets. For example, here. So I'm creating this object returns, and then I'm using monthly return, and the object is prices. Okay? Type is equal to log. Let's see what happens here, class. Let me just share this with you so that so it's almost time, class. If you need to go, I'll just extend a few minutes lang. No? So the rest of you who need to go, you may do so. Anyway, i-record naman natin to. No? All right. So here, I'm using prices. I'm not defining any asset in prices. But if we run this, what happens? Did it give us all the monthly returns? No, class. No, only one. So the question is, what's this, class? What's this? Which asset was this? Okay, was it the Apple? Was it GSPC? So I'd like you to find out, class, ano nangyari dito? Okay, what happened here? Okay, how was this computed by quantmod? Kasi yung object natin na prices, it contains several assets. So what do you think? What do you think happened, class? Okay, isa lang kasi, no? So next meeting, class, we're going to already use this function, this library performance analytics. So make sure you have already loaded this. Okay? Kasi ito, class, gagamit tayo ng performance analytics will allow us to. Okay, so pakiran na lang ito, class. Ito na lang. I'll end in this. So pakiload, class, yung ano, pakiload yung performance analytics. I think we have loaded this before. And then I'll share this with you. And Control C. Compare, class, what happens with this function. All right. With this function, take a look at this. So I'm creating this object called port returns. Using the performance analytics, I'm using this function return.calculate, and then the object is prices, and then method is equal to log, and then let's view this. So if I run this, class, okay, what happened? Now you can see it computed the daily prices, return.calculate, for all the assets. Unlike the one that we were using for quantmod, daily return, weekly return, if you use the prices there, it will only generate one value. The question is, what is that one value? On the other hand, class, itong return.calculate na to, okay, from the performance analytics package, it generated all. Di ba lahat ng mga returns, and nag-default siya sa daily returns. Okay? All right. So with that, class, we end our discussion for today. Let me stop recording now. And we'll